Have you ever had a brilliant idea for a gadget, but then you just stop because you have no idea how to actually make it real? Well, you're in exactly the right place. Today, we're going to break down all that complicated sounding stuff, electronics, programming, into some really simple, powerful building blocks. The kind that'll help you turn those ideas into actual inventions. So here's our game plan. We're going to start with the spark, the electricity that powers everything. Then we'll move to the playground where we build our circuits. After that, we'll learn how to add some control, give our project a brain with a little bit of code, and finally, see how it all comes together so you can start prototyping your own ideas. Okay, let's start with the absolute foundation, the one thing you can't do without: electricity. You can think of it as this invisible energy that we're about to learn how to control and shape to do whatever we want. Now, to harness that energy, we need something called a circuit. And honestly, the best way to think of a circuit is like a racetrack for electricity. And just like a racetrack, it has to be a complete, unbroken loop for the race to even begin. And you know what's great? A basic circuit is actually super simple. You really only need three things: a power source, like this battery here, a path for the electricity to travel, which are the wires, and components that do the actual work, like this resistor and this little LED light. The electricity flows from the positive side, goes through everything, and then comes back to the negative side. See? A complete circle. And this brings us to probably the most important rule in electronics. Seriously, this is the first thing you should always check when something isn't working. Is your circuit complete, or is it open? An open circuit, as you can see, has a break in it. The electricity just hits a dead end. But a complete circuit is a nice, closed loop, and that's when the magic happens. And yeah, this slide shows it perfectly. Just look at that image on the left. That tiny little gap between the wire and the resistor, that creates an open circuit, so no light. But as soon as you close that gap, like in the right image, boom, the path is complete. It's such a simple mistake, but trust me, it gets everyone when they're starting out. Now, if you want to sound like you know what you're talking about, there are three key terms you got to know. And the easiest way to remember them is to just think about water flowing through pipes. Voltage is like the water pressure. It's the push. Current is the flow rate, how much water is moving. And resistance, that's like making the pipe narrower. It slows that flow down. All right, so we've got the power figured out, but where do we actually build these circuits without making a huge mess? Well, welcome to our playground, the breadboard. Think of it like a Lego base plate, but for electronics. No soldering, no permanent connections, just pure, easy experimentation. So how does this thing even work? Well, underneath this grid of holes, there are these hidden metal clips that connect them. On the sides, you have what are called vertical power rails, and those run the entire length of the board. And then in the middle section, you have these horizontal terminal strips. This just means that every single hole in a numbered row is connected to all the other holes in that same row. Okay, let's put that to the test. Time for a quick pop quiz. Take a look at this breadboard. We've got one wire plugged into hole A8 and another one plugged into H8. So are they electrically connected? What do you think? And the answer is nope, they're not connected. And this is actually a really important feature. That big channel running right down the middle of the breadboard is a complete gap. It separates the left side from the right, which is perfect for plugging in computer chips and other parts without accidentally shorting them out. Okay, one more for you. This time we have three wires, all in row 8 at positions A, C, and E. Are these three connected to each other? Yes, absolutely. Because they're all in the same numbered row and on the same side of that center gap, that metal clip underneath connects all of them together. Once you get this one simple rule, you can build pretty much anything you can imagine on a breadboard. So we have our power and we have our playground. Now it's time to add some control. That's where our components come in. These are all the little parts that let us interact with our circuit and, make it do interesting things. Let's start with the most basic form of control you can have, a simple switch. I absolutely love this analogy on the slide. Think of it like a drawbridge. When you press the switch, you're closing the bridge, which completes the circuit and lets all that traffic, the electricity, flow right through. But, not all switches are created equal. Maintained switches are like your light switches at home. You flip them and they stay in that position. Momentary switches, like a key on your keyboard, are only active while you're actually pressing them. They can also be what's called normally open, meaning the circuit is off until you press it, or normally closed, where the circuit is actually on by default. Okay, we've covered all the physical stuff. Power, structure, control. But what if we want our creation to be smart? to make decisions on its own? Well, for that, we need to give it a brain. And that's the final piece of our puzzle, moving from hardware to software and using code to bring our project to life. So when you're ready to start coding, especially on something like a Raspberry Pi, you've got options. Nano is a simple text editor that runs right in the command line. It's fine. But for beginners, I highly recommend Thani. It's a full programming environment that's way more user-friendly and just perfect for getting started with Python. Let's write our very first program. It's so simple. First, we use the input function to ask the user a question. Whatever they type in gets stored in this little digital box, we call it a variable, that we've labeled name. Then, we do the exact same thing to find out their favorite place. And for the final step, we use the print function to show our result. We give it some text inside quotation marks, and then we just use the plus sign to stick the information from our name and place variables right into the sentence. And there it is. That's the whole program. Oh, and those lines that start with a hash symbol, those are just comments. They're notes for us humans that the computer completely ignores. Look at that. Just 3 simple lines of actual code, and you've made an interactive program. Now imagine, with just a few more lines, this same code could tell that LED we saw earlier to blink or turn on when you press a button. That's the real power of software. Okay, let's bring it all home. We've got electricity for power, a breadboard for our playground, components for control, and code for a brain. This is the payoff. This is where you get to combine all these building blocks to start prototyping your own unique ideas. This slide just says it all, doesn't it? The circuit on the left is soldered, which means it's permanent. But the circuit on the right, built on a breadboard, is completely flexible. You can build something, test it, and change your design in a matter of seconds. The breadboard is basically your personal sandbox for invention, letting you try out ideas really quickly and easily. And just like that, you now have all the essential building blocks. You've got power, structure, control, and intelligence. You have what you need to create pretty much any electronic gadget you can dream up. The only limit, really, is your imagination. So the real question is, what are you going to create first?